Hi there, science fans, welcome to our chemistry lab, where today we're diving into the awesome world of separating substances. We've got 4 incredible processes to explore: crystallization, centrifugation, chromatography, and sublimation. These techniques aren't just for scientists, they're happening all around us. From the sugar in your candy to the medicine you take, these methods play a vital role in our daily lives. So, put on your thinking caps, because we're about to embark on a scientific adventure that's sure to amaze you. Let's get to it. Let's kick things off with crystallization. That phrase crystal clear comes from this process, where pure substances form right before our eyes. It all boils down to solubility, how much of something can dissolve in a liquid. When we heat up a solution, we can usually dissolve more stuff in it. As the solution cools, the solubility decreases, and the dissolved stuff starts to come out, forming beautiful crystals. Think of it like making rock candy. You dissolve sugar in hot water until you can't dissolve anymore. That's a saturated solution. Then as it cools, sugar molecules bond together, forming sparkly sugar crystals. Crystallization is crucial for purifying things, from the salt we sprinkle on our food to the silicon used in our computers. It's a shining example of how science can take something simple and turn it into something incredibly useful. Alright, Science Squad, buckle up because we're about to get spinny with centrifugation. Imagine a merry-go-round spinning so fast that things start flying off. That's kind of what happens in a centrifuge, but instead of people, we're spinning test tubes filled with mixtures. Centrifugation uses spinning force to separate substances based on their density. Density is just how much mass is packed into a given space. Think about a bowling ball and a beach ball. They might be the same size, but the bowling ball is much denser. In a centrifuge, denser particles get pushed outward, while lighter particles stay closer to the center. This technique is a lifesaver, literally. In hospitals, centrifuges separate blood components. When blood is spun, red blood cells settle at the bottom, while plasma forms a layer on top. This separation is crucial for blood transfusions and other medical procedures. Centrifugation is also used to make your favorite dairy products. By spinning milk at high speeds, we can separate the lighter cream from the denser milk. Pretty neat, right? So next time you see a salad spinner drying your lettuce, remember it's a mini centrifuge in action. Get ready to unleash your inner artist, science sleuths, because it's time for chromatography. This technique separates mixtures based on how different substances travel through a material. Think of it like a race where each runner has a different speed. Imagine you spill some black ink on a piece of paper. At first glance, it just looks like a dark blob. But black ink is actually a mixture of different colored dyes. With chromatography, we can reveal those hidden colors. Here's how it works. Place a drop of the black ink on a strip of filter paper and dip the edge into a solvent, like water or alcohol. As the solvent travels up the paper, it carries the different dyes with it. Each dye has a different attraction to the paper and the solvent, so they travel at different speeds. The dyes that are more attracted to the solvent will travel further up the paper, while the dyes more attracted to the paper will move more slowly. As a result, the different dyes in the ink separate out, creating a beautiful pattern of colors on the paper. It's like magic, but it's science. Chromatography is used in all sorts of cool ways, from testing the purity of pharmaceuticals to analyzing the chemicals in food. It even helps forensic scientists solve crimes by separating out the components of ink from a pen used to write a note. How cool is that? Fasten your seatbelts, science explorers, because we're about to enter the world of disappearing solids with sublimation. This process is like a magic trick where a solid transforms directly into a gas, skipping the liquid phase altogether. Think of dry ice, which is solid carbon dioxide. When you leave dry ice out at room temperature, it doesn't melt into a puddle like regular ice. Instead, it sublimates, going directly from a solid to a gas. That's why you see that spooky fog around dry ice. It's not smoke, it's carbon dioxide gas. Sublimation happens because some substances have a high vapor pressure, meaning their molecules can easily escape from the solid state and enter the gas phase. It's like they're so eager to become a gas that they skip the liquid stage entirely. This unique property makes sublimation a super useful technique for purification. For instance, if you have a mixture of sand and iodine and you want to separate them, you can use sublimation. When you heat the mixture, the iodine, which sublimates easily, turns into a purple vapor, leaving the sand behind. Then you can cool the vapor and the iodine will solidify back into its pure form. It's like a disappearing act for impurities. Sublimation is also used to create those cool, freeze-dried foods that astronauts take to space. By freezing the food and then sublimating the ice, we can remove the water without cooking the food, preserving its nutrients and flavor. So, next time you see something vanish into thin air, remember, it might just be sublimation in action. And there you have it. Crystallization, centrifugation, chromatography, and sublimation, explained with everyday examples. These processes are not just fascinating but incredibly practical in science and industry. From the food we eat to the medicine we take, these techniques play a crucial role in our lives. Remember, science is everywhere, and it's always full of surprises. Until next time, keep experimenting and stay curious. Don't forget to like, subscribe, and share this video with your friends.